Hello, welcome to another session of computing the square. Today I'll be attempting to show one method of computing the square. Alright, so let's begin. So computing the square applies for quadratic expressions. Alright, so a linear expression cannot be used for computing the square. It must be quadratic. Or when I say quadratic, it must satisfy ax squared plus bx plus c. That is, it must have some numerical values for a, b, and c. Alright, and the key point to note is that the highest power of x is 2. Alright, so this applies for a quadratic expression. So first things first, let's all check and see if your expression qualifies and fits as a quadratic expression. If it does not, then we are no longer working at quadratic, and then computing the square method will not work. So there's one cautionary note to point out. Alright, so the first case I'm looking at is when my value of a is 1. Alright, so we have x squared to work with. Okay, so from here we are going to look at a work example and then we shall continue. For this example, I shall be using x squared minus 4x plus 3. Is this a quadratic? Let's examine. Does it satisfy ax squared plus bx plus c? Let's examine it. Here my a is 1, my b is negative 4, and my c is 3. Here the highest power of x is 2. So this fits and qualifies as quadratic. So we can move on now to actually performing the steps involved. Okay, let's go ahead now and let's complete the square of this. So we have a scenario whereby our a, the value of a is 1. Alright, that you have, in this case you have x squared. So what are the steps involved? Well, the steps involved are very simple. You could group all the x squared and x terms together in number terms by itself. And then we're going to take the half of the coefficient of b, right? We're going to take half of b and then square it. So you add this here and then you subtract. So when you add here and then you subtract, now you're adding half of the coefficient of b, adding half of b or b squared, and then subtracting half of b or b squared. So you add and subtract, the net effect is 0. So you add this and then you subtract it. Guess what? The net effect is 0. We're not doing anything much there. And when you add half of b and you square it, what you end up doing is generating a perfect square. And afterwards, simplify everything. So these are the basic steps involved. Alright, so let's apply this into our problem. So in this example, we have x squared minus 4x plus 3. A is equal to 1, b is equal to minus 4, negative 4, c is equal to 3. The highest power of x here is 2. So this qualifies and fits as a quadratic. So what are the steps involved? The very first thing we have to do is to isolate all the x and x squared terms. And the number terms put it by itself. Alright, so we have x squared minus 4x plus 3. So the first thing we do, we group together all the x and x squared terms. We put it together. So all the x squared and x terms are placed together. And then we put the number terms by itself. So by doing this, we actually lump this together into one big bracket. Alright, this comes here into one big bracket. See that? One big bracket. And the number term put it by itself, one set. From here, we examine what is the value of b. Alright, here the value of b is negative 4. So the value of b here is negative 4. So we add half of b and we square it. So here we add this here, and then we come and subtract it again. The value of b divided by 2 square, we subtract. So we add here and we subtract. The net effect is 0. Alright, so the balance here is actually 0. Alright, you get a 0 contribution. Alright, so when you do this, we're going to simplify this. So upon further simplification, we realize that negative 4 on 2 is really negative 2 or minus 2. So this really boils down to minus 2. So this here is really minus 2 all to the square. Similarly, here is minus 2 all to the square, or negative 2 all to the square. On this side, we have to pay attention to our sign. Here, we also need to pay attention to our side. Alright, minus 2 all to the square is 4. Alright. Now the next point to note, x squared minus 4x plus minus 2 all to the square. This here becomes x minus 2 all to the square. This here is the same as x minus 2 all to the square. This expression here, this piece here in blue, forms the perfect square. This is the perfect square piece. This portion becomes the perfect square. Alright, so we need to simplify the number terms here on this side of it. Hence the reason why I use black. Alright, I use black just to denote the number terms. Alright, so simplifying the number term side, we have 3 minus 4. Alright, minus 2 all to the square is really minus 2 times minus 2. Minus 2 multiplied by minus 2, which becomes positive 4. But because you have this sign on the outside here, it becomes negative 4, because minus 4. This really becomes 3 minus 4, which is really minus 1. So, to wrap up now, right, this expression in blue is really x minus 2 all to the square. This is perfect square piece. So this here is x minus 2 all to the square minus 1. Right? Let's bring it back into the form a open bracket x plus h all to the square plus t. In this case, our a is 1, our h is minus 2, and our t is negative 1 and minus 1. Alright, to summarize now, x squared minus 4x plus 3 is equivalent to x minus 2 all to the square minus 1. Alright, this is how we go about completing square for when a is equal to 1. See that? Our a here is equal to 1. This is how we go about doing this. Alright? Okay, thank you. I hope you learned something beneficial to everyone. And I use this knowledge to benefit everyone and better humanity. Please like and share. Thank you. Have a great day. Please like and subscribe.